So we have talked about factoring if we're given a factor, like something we can't factor or something we can't solve. If they give us a starting point, then we can go from there, right? Give me a factor or give me a zero and I can take it from there. But what if you don't have any of that? For example, what if I just told you to factor x to the third plus 2x squared minus 11x plus 12. And I said, just factor it. You would probably look at that and go, oh, geez, I don't even know where to start, right? Because you can't slash it. It won't group. It won't do anything. It's not anything special. So what we use are something called PRZs, and they're exactly what it sounds like. They're possibilities. They may or may not work, okay? So when we list them, what we do is we take all the factors of the constant. Now, what's the constant? The number without a variable. And we divide it by all the factors of the leading coefficient. What's the leading coefficient? That's right. When it's in standard form, important to remember that it must be in standard form when you do this. All right, standard form meaning biggest exponent. So here, the leading coefficient is 1, and the constant is 12. So tell me, what are the factors of 12? 1 and 12. I'm going to say plus or minus, right? Because they can be negative too. 1, I heard 2. I'm going to go in numerical order here to make my life easier. 3, 4, somebody said 6, and 12. Those are all the factors of 12, right? How about the factors of 1? Just 1, right? So to find the PRZs, I would take all of these numbers and divide them by all of the factors of leading coefficient. In this case, it's only 1. So the PRZs, or the possibilities, the ones that might be zeros, are plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 4, plus or minus 6, and plus or minus 12. Because when I divide them by 1, it just gives me itself, right? Now, had that been a 2 in the front, like let's say this was 2x cubed, well, the factors of 2 are 1 and 2, right? And so then that would mean that I would also have to take all of these. I've already divided them by 1, but now I'd also have to divide them by 2. So I'd have plus or minus 1/2. Well, 2 divided by 2 is 1. It's already on that list. There's no sense in repeating it. 3 divided by 2. 4 divided by 2 is 2, so that's already on there. 6 divided by 2 is already on there. And so here's why we use these. We need a starting point, right? We already established that we need a starting point. We don't know how to factor the way it sits right now. But if they gave us a factor or they gave us a 0. So what we're going to use these almost like a starting point. We're going to start checking them to see which one of them might actually be a 0, so then I can find an actual factor. So how do you think I might be able to check a PRZ? Divide. How would you know when you got the right one? If there's no remainder. And then at that point it picks up and we solve just like we did before. So let me give you an example that we'll do start to finish using PRZs so that you'll really see. Let me do one that does not have a leading coefficient of 1. I have a note in my book next to this one. Never use this as the first example.
Why?
That must have been bad. This is a good one. Well, let's not do. Let's do one with we'll do one with a leading coefficient of 1, and then we'll do a little bit harder one. Let's say f of x equals x to the third minus 8x squared plus 5x plus 14. And the directions say find all zeros of the function. And we know that to find zeros, we need to factor, set each piece to 0, and solve, right? Okay. So I definitely can't slash this one. So as I look at it, I'm going to have to do PRZs because I don't have a starting point.
Does it matter like the numbers you chose?
It will, but not when you're listing PRZs. It's not a quadratic. it's a cubic. If it was a quadratic, you could. No, it's not. What are the PRZs?
1,
1,
2,
2.
7.
Because the leading coefficient is 1, right? Makes it easy. All right, so now what I need to do is start testing them. I don't care what you start with. Start with whatever you want. 1's probably going to be the easiest to start with. So let's start. Hello. 1, if I divide, don't forget placeholders should you need them. Now you see why synthetic is your best friend? You were doing this long division. Oh my gosh. All right. You got to do them until you find one that works. 1, -7, -7, -2, -2, 12. Does that one work? No. So maybe I should try -1.
Oh my God. This is what you're joking, right?
See, I think this is fun.
That's like a lot of people.
You only have to find one. How many does it have? No, look. 3. It has 3. Good job. It has 3. I only have to find one that works to springboard me, to give me a starting point.
All right, well, we know -1.
How do you know that, Wills?
Because 1 didn't work.
So you assume that because 1 did not work?
Yeah. -1 works.
Oh, it sure does.
It sure does.
I knew it did. That's why whenever y'all said that, I was like, what? So yes, do not assume because the positive does not work that the negative will also not work. All right, so now I have that place that I needed. I have that hint that I needed to get started. Now the problem becomes find all zeros given a 0, right? Because now I know one of the zeros is -1. So if one of the zeros is -1, that means that in fact, and I've already divided it too. So write it for me in factored form. Times what? What was that first factor? I got to include that. Remember, they didn't give it to me this time. I found that on my own. Because I'm smart. That's right. -7 and -2. And so the zeros are -1, 7, and 2. All of which were on that list. They won't always be on that list, but in this case they were. Yes? Because I divided by -1, that means it was a 0. Because it went in, so that means x minus whatever's on the outside when you get 0 is a factor. Let me ask you this. I'm fixing to make you think you know that. Whenever I say that, you know I'm fixing to like. What if I got to this point and this was not a quadratic? Because if it was a CBF, I could put in quadratic formula and be done with it, right? But what if that was a CBF that was like a power of 3 that I couldn't factor? Well, what if it was like this? What if I had x plus 1 times x to the third minus 8x squared plus 5x minus 7? It won't group.
Wait, hang on.
It won't group.
What was the question?
Yes.
Do it again.
Yes. You could continually PRZ until you got it completely factored. Will you have a double PRZ on your test?
Yeah.
Yes, because they're so much fun. Let's do another example. Let's kick it up a notch. Because that one was easy peasy.
It was.
If you're watching this video, Miss McGee will be getting arcade good.
Yeah, Judge's square roots are pretty
It's
nasty.
like really easy. All you do, all
It's everything we've done. Just put it into one. Yeah.
Wait, what? Well, I mean, like, I'm just trying to understand.
What are the PRZs?
I'm trying to understand.
Because y'all don't even know how to factor any shortcuts with a power of 4. I mean, that's just. All right. Oh yeah. All right. So 1, 2, 3, 4, 6, 12. Is that it? That's just the factors of 12. Now I have to divide them because now I've got a leading coefficient of 9. And the factors of 9 are 1, 3, and 9, right? So I've already divided them all by 1. Now I've got to divide them by 3. 1/3. 2/3. 3 divided by 3 is, that's already on the list. 4/3. 6 divided by 3 is 2. 12 divided by 3 is 4. So those are good. Yes. I'm going to put it under just so you see. 1/9. 2/9. 3/9 is 1/3. That's already on there. 4/9.
And she's got back and she's like,
6/9 is 2/3. 12/9 is 4/3. So that's all of them. Remember, it's factors of the constant divided by factors of the leading coefficient. These are all the factors of the constant. But the leading coefficient, so this is when I divided all these by 1. Then I divided them all by 3, because that's a factor of the leading coefficient. Then I divided them all by 9. You just pray that you have one that's a leading coefficient of 1. Because that's the... Yep. Just to list the PRZs now.
You better not make us like. You better not make us go through the entire list.
last time I
Okay.
was going that day and I left for lunch, they said I. Wait, what's the annual?
Oh my goodness, we have, wait, what? Hold. All right, start picking them. Start guessing.
I've always tried 2.
I hear 2, I hear 3. Because I'm looking at the answer in the book, I'm gonna try 1.
I tried 1 too.
Did it work?
I don't know, because I'm trying to do negative.
I tried 1, but I don't know. 9, 9, 12, 12. -18, -18, -12, and -12. Hallelujah. It worked, but I have x minus 1 times.
Not x try.
Yes.
Yeah, not x try. 12x, 18x, 12.
Now, hold the phone. Well, we're definitely going to try. I can definitely take a GCF out. I see that right off the bat. They're all divisible by what? 3. Take that 3 out. Too fast?
Yeah, wait. Like,
Okay. 3x to the 3rd. I'm just taking out, that's a crappy 3. I'm just taking the 3 out of everything. Now, Silas says we can group this. We can... I'm not convinced. So, in looking at this, I can't slash it. It's not a quadratic, so I can't use quadratic formula. I got a PRZ. So this time, I love these problems. I am not going to lie. They are so much fun. This is going to be a double PRZ quadratic formula problem, and I love it. Okay. I'm not. Mine's electronic.
I am over here.
Sure. You write your notes on your tablet. All right. You actually have this software on your computer. They put it on y'all's too.
Well, when I first got it, I opened it.
Time. All right, so I do need to PRZ it one more time. So factors of the of the constant divided by factors of
3 and 4 and 5 and 6 and 7 and 8 and 9.
No, what?
We're talking about 4.
We're talking about 4 and 3. So I divided them all by 1. Now I'm going to divide them all by 3. Significantly smaller amount of PRZs. They are definitely not all this long. This is the hardest it will get for sure. Yeah.
Oh, it will.
Unless it's a bonus question. Yes. No. Because I'm only looking to factor this piece. I just don't know how to factor that at this point. All right. So let's start trying pieces. For the sake of time, yes. If I do -2, I feel like if you're savvy graphing, you could graph it and look at where it crosses the x-axis, because essentially you're just finding 0.
Yeah, but then where's all the order come from?
Well, it would give you, just like mine, it would give you a hint as to where to start instead of plugging.
A lot of the yellow ones.
No. -6, -2, 4, -2, 4, 0. Look at us magically picking the right one first. They're magically delicious. Okay. So now, now this factors as 3x minus 1. That is still there. It has not gone anywhere.
Oh.
This tells me that one of the factors is x plus 2. And now I have 3x squared minus 2x minus 2. Oh, just wait. You might want to flip over to the next page.
I can imagine our homework, so maybe like 5 pages long.
Please don't tell me there's like 100 questions on that.
100, just 102. I'll cut it down to 95 just because you asked so nicely. All right. I'm picking, Palmer. Okay. So everything goes to 0, right?
Guess what?
But guess what? It can't frickin' factor, which means I have to do what?
The quadratic formula.
Yes!
Oh my god.
I
I promise you I'm not coming to school tomorrow.
Remember I told you at the end of chapter 2, we would hit a lesson that would be so cumulative that I could give you one problem and build enough stuff in that one problem that I could test you on a lot of the stuff from chapter 1 and everything in chapter 2. Here it is.
After every note that I make it through.
You did that this week?
Wait.
I would.
Alright.
That's for when you get to college. You will have stuff like that when you get to college where they'll just put everything. Here's one problem. Good luck. It's your test. And it's one of your 2 grades for the semester. 4AC all over 2A. Good thing is, y'all know your quadratic formula because, well, you did those videos. 24 and 4 is 28. 4 can come out of that. I'm out of room myself. 2 root 7 over 6. Everybody can get divided by 2. I hate this and I'm sorry, but I have to come over here to do the last little. 1 plus or minus the square root of 7 over 3. There's 2 solutions, 3 solutions, 4 solutions. Did I start with a power of 4?
Yes.